Welcome to Ask and Learn.
Hello everyone. In this problem, a series parallel combination of resistive, inductive and capacitive circuit is given, which have a current source, and the value of this current source is 5 angle of 0 degree ampere, which have 5 of magnitude and phase angle is 0 degree, and the element are connected: a resistor, an inductor and a capacitor of, and again a resistor of, and here a one capacitor is on. Okay, and the value of these element are 2 ohm minus iota, 2 ohm, iota, 4 ohm minus iota, 2 ohm and 2 ohm. And find out the value of current I naught across resistor 2 ohm. Okay, so first we have to calculate the total impedance of the circuit. Okay, basically there are three methods to solve this problem. First method is that we have to convert this current source into voltage source and apply the KVL in all these three loops, and by solving these KVL equation we can easily calculate the value of current I naught. And another method is by applying the node voltage method on these node, we can easily calculate the value of current I naught. Fine. And the third method is current division rule, which is the simplest method for solving this problem. So we have applied the current division rule in this problem. Now what about the current division rule? The current division rule says if two branches are connected in exact parallel like that, if two branches are connected in exact parallel and a current I is flowing in this branch, assume this is the Z1, this is the Z2, and total current I, current across Z1 is I1, current across Z2 is I2. Then the current in branch of interest can be calculated by using, for example, if we want to calculate the value of current I2. So first we put the opposite branch impedance Z1 upon Z1 plus Z2 into total current I, which gives the value of I2. If you want to calculate the value of current I1, then we put Z2 upon Z1 plus Z2 into total current I. Okay, so first we have to convert this circuit in two branch circuit. Okay, so here assume this is the impedance Z1 and assume this is the impedance Z2. Fine. So what about the Z1? Z1 is minus iota 2 ohm. And what about the Z2? Z2 is simply this resistor and this capacitor are connected in parallel, and the parallel combination of these two elements are connected in series with this inductor. Okay, so now what about the Z2? Z2 is iota 4 plus, these are connected in parallel, so minus iota 2 ohm parallel 2. Fine. So now what about the value of Z2? The Z2 is given iota 4 plus minus iota 4 upon 2 minus iota 2 equals to 1 plus iota 3. Okay, this is the value of Z2, sorry. So rearranging the circuit, this gives the value current source 5 angle 0 degree and series resistance 2 ohm, impedance Z1, and this is the impedance Z2, right? This is the current I, which have the value of 5 angle 0 degree. This is Z1, this is Z2. Current I1, current I2. So first we have to calculate the value of current I2. Then further we extend this circuit, right? So current I2 is given Z1 upon Z1 plus Z2 into total current I. The current in the resistance 2 ohm is same because this is connected in series across. Okay. So now I2 will be, what about the Z1? Minus iota 2 upon minus iota 2 plus 1 plus iota 3. Put this value 1 plus iota 3 and this is minus iota 2. Okay. Multiply by 5 angle 0. Then the value of current I2 will be minus iota 10 upon 1 plus iota. This is the value of current I2. Fine. So now again rearranging the circuit, if we extend the value of Z2, then what is the value? It is inductor, here capacitor, and resistor 2 ohm. This is the current I0 and this is the current I2, which is iota 4 iota 2. So again we have to find out where the value of I2 will be, this one. Then again apply again current division rule. Then what about I0? I0 will be, we have to have I0 across 2 ohm resistor. So then in opposite branch impedance is minus iota 2 upon total impedance 2 minus iota 2 multiply by total current I2, which is minus iota 10 upon 1 plus iota. Now by solving this equation, I0 will be minus 10 upon 1 plus 1, which is minus 5 ampere. Fine. Now this is the resultant current I0 across 2 ohm resistor. Okay. So now in this circuit, a series parallel combination of RLC circuit is given, and these are connected across a 5 ampere current source. Now by applying simply a current division rule, by solving series parallel combination, we can easily calculate the value of current I0 across the load resistance RL, which is the 2 ohm. Thank you.